So what if you could give any robot a state-of-the-art brain, completely for free? Well, that's pretty much the promise of OpenVLA. It's a powerful, new open-source AI model, and it's poised to totally shake up the world of robotics. But to really get why this is such a huge deal, we've got to start with a really simple question.
I mean, it sounds so simple, right? Wipe the table. But for a robot, that one little command is actually this monumental challenge. It has to see the table, it has to understand what wipe even means in the physical world, find a cloth, and then figure out this whole complex dance of movements to actually do the job. You see, this gap between our words and a robot's actions, that's been one of the biggest hurdles in robotics for a long, long time.
So to really appreciate why a model like OpenVLA is so revolutionary, we need to talk about the problem it's designed to solve. And that's the fact that, for decades, the best AI for robots has been kept behind lock and key.
For years, the most powerful robot brains were all cooked up in-house at these massive tech corporations. They're totally closed-source, proprietary, you can't get your hands on them. This creates this kind of walled garden where only a handful of people can really innovate. And what that means is progress gets slow, it gets expensive, and it completely locks out all the students, the university labs, and the hobbyists who could be pushing this field forward.
Okay. So how do you break open that locked box? Well, you build a new key, an open-source brain that literally anyone can use. And that, right there, is exactly what OpenVLA is all about.
So what exactly is this thing? OpenVLA is what's called a Vision Language Action Model, or VLA for short. Now, that's just a fancy way of saying it connects three really crucial dots: what a robot sees with its cameras, what you tell it to do in plain English, and then what it actually needs to do as a physical action. See, understand, and act. It's a direct bridge from our words to the real world.
Let's pop the hood for a sec. First up is vision. You can think of OpenVLA as having two eyes. One part is fantastic at understanding where things are, the spatial layout. The other is amazing at figuring out what things are. Then comes language. The famous Llama 2 model takes in all that visual info plus your command and makes sense of it. And finally, action. The model spits out these super precise 7-dimensional commands, which again is just a technical way of saying it's controlling the robot arm's exact position, its rotation, and even its gripper, all at the same time.
So the recipe for this brain is basically a combination of all the best open-source ingredients you can find. It's built on a really strong visual model, it uses the Llama 2 language brain, and, this part is critical, it was trained on this huge data set of almost 1 million real-world robot demonstrations. But you know what the best part is? Everything. The data, the code, the final model, it's all completely open source for anyone to download and build on.
All right, so the recipe sounds amazing, but how does it actually perform? Does it work? Let's see how this open-source brain actually stacks up against the closed-source competition.
And this is where it gets really, really interesting. We've got a classic David versus Goliath situation here. In one corner, you have our open source model OpenVLA at 7 billion parameters, and in the other corner, you've got the closed source champ from Google RT2X with a whopping 55 billion parameters. That is almost 8 times bigger. All the money should be on the bigger model winning, right?
Well, the results are in, and honestly, they're kind of stunning. Just look at this. On a major industry benchmark, the little guy, OpenVLA, doesn't just beat the massive RG2X model. It completely leaves it in the dust. It's not even close. This isn't just a win, it's a huge statement. It proves that a smarter design with better data can totally beat raw brute force size.
Let's just put a number on that win, because it's pretty wild. The paper points to a 16.5% absolute jump in success rate over the old state-of-the-art. Now, in the world of AI research, an improvement that big isn't just a small step forward. It's a massive leap. It's a whole new ballgame.
So, where is this huge advantage coming from? Well, it all comes down to one word: generalization. Just focus in on that physical row there. That's a test of how the robot handles new objects it's never seen before. OpenVLA is hitting almost 77% success, while the much larger model is stuck under 27%. That is the key. It is dramatically better at adapting to the messy, unpredictable real world.
But you might be wondering, was that just a fluke? Maybe it was just one specific test. Well, to check that, the researchers tested OpenVLA on Google's own robot platform. And look at this. Even playing on its competitor's home turf, the smaller OpenVLA still performs incredibly well. This proves its performance is the real deal, and it works across different kinds of robots.
So yeah, OpenVLA is the new champion. But its performance, believe it or not, is only half the story.
The true revolution here is that this champion brain is now available to everyone.
This is the million-dollar question, isn't it? A 7 billion parameter model? That sounds like something that needs a supercomputer in a government lab. Can a student in their dorm room or a small startup actually build something with this? Well, the answer, surprisingly, is yes.
And this is where the engineering just gets so clever. If you wanted to fully retrain a model this big, you'd need over 160 gigs of VRAM. Nobody has that. But by using this really smart technique called LoRA, which is kind of like freezing the main brain and just training a tiny little adapter for it, you only have to tweak about 1.4% of the whole thing. And the result? You get basically the exact same performance while slashing the computer power you need.
The paper puts it perfectly. This technique means teaching a robot a new skill goes from being this massive, week-long project on a whole rack of GPUs to something you can just run overnight on a single machine. That's an 8 times reduction in compute, which makes cutting-edge robotics research way more accessible.
Okay, so training is more accessible. But what about just running the robot day to day? Well, that's where another trick called quantization comes into play. You can think of it like compressing a giant photo. You just make the numbers inside the model a little less precise, and that shrinks its size. And look at that int4 row. It cuts the memory you need by more than half, down to just 7 gigabytes, with 0 drop in performance. That is well within the reach of a modern gaming GPU that you could have at home right now.
So, what's the bottom line here? It's this. OpenVLA doesn't just set a new bar for performance, it completely demolishes the barrier to entry. It's taking the world's most advanced robot AI out of the exclusive labs of a few tech giants and putting it right into the hands of innovators everywhere. And this really brings us to the most exciting question of all. When you give thousands of brilliant researchers and students and creators access to a tool this powerful, what happens next? The bottleneck for progress is no longer about who has the biggest computer, it's about the limits of our own imagination. With an open source brain for every robot, the next great leap forward could come from absolutely anywhere. The only question is, what's it going to be?